Hey guys, today we're gonna continue talking about topic 11. We talked about square root or radical functions in the last video, but today we're going to focus on square root or radical equations. So we're still gonna have the radical, right? Either the square root or any type of radical, but now we're gonna have equations where there's an equal sign and we're going to have to solve for the variable. Okay, so some vocabulary first. So it says a radical equation is an equation that has a variable and a radicand or a variable with a rational exponent. If the radical has index 2, the equation is called a square root equation. Okay, so when they say radicand, they just mean the symbol. Let me show you. So the word radicand just means this, okay? So this symbol, the radical, it can have any index technically, right? Now we're used to seeing it with no index, right? And remember, if there's no index, the implied index is actually 2, right? But, you could have the cube root, you could have the fourth root, you could have the sixth root, but those are just not as common. But any equation that has the radical symbol is considered a radical equation. Now, when it's specifically an index of 2, which remember, when we don't see the actual index, we can assume that the index is 2. So that's called a square root equation. So any equation that has this symbol, right, which technically has an index of 2. Okay, so there are two important things I want you to remember when you're solving for the variable. Let's just say it's x, right? So when solving radical equations, the two things I really want you to jot down and just make sure you're aware of is one, your goal is to really isolate your radical first, and then we can get rid of the radical using some algebra. Okay? I mean, you do have to use algebra to isolate your radical, but by getting it by itself, it makes the rest of the problem really easy. And part 2. So it says make sure to check for extraneous solutions by plugging back in. So we've talked about extraneous solutions before. Remember, an extraneous solution is just an extra solution that you get when you solve an equation, but then when you actually go and plug it back in, it doesn't actually work. Maybe when we were doing rational equations, remember we would get sometimes solutions that would make the denominator 0, which we couldn't use, or sometimes we would get a solution, plug it back in, and even though it was the correct solution that we got as we solved our problem, when we plugged it back in, it didn't actually make both sides equal. So that was considered an extraneous solution. So unfortunately, it's an extra step, and sometimes it's a long extra step because you have to go back and plug things in, and sometimes you'll have more than one solution, so you're doing the plugging in twice. But it is important that you do that, okay? So those are the two main things I want you to remember. So pause this slide if you haven't jotted these down. Make sure you write them down in your notebook. Okay? Another thing is that I want you to remember something that we covered before. Okay? Anytime you have a radical, you can represent that as an exponent. So for example, square root of a can be represented as a to the 1/2 power. Okay, so where did the 1 and 2 come from? Remember, here the index is 2 and the a is being raised to the first power. So the exponent becomes the numerator, the index becomes the denominator. So something like, cube root of m to the second power is the same thing as m to the 2/3 power. Okay? So I want you to remember this property because we will also use it when we solve radical problems, because sometimes they'll give us radical problems that are actually fractional exponents. So because they are fractional exponents, we can convert them back to radicals, we can kind of play around with them, but you need to know how to convert from a radical to a rational exponent, like a fractional exponent, and vice versa. Okay? All right, moving on to example 1. Okay, so they want us to solve for x, and the equation is the following. 3 plus square root of 2x minus 3 equals 8. Okay, so as you can see, this is a square root equation, right? This is a square root equation. So it's a square root because it has a radical with technically an index of 2, and it's an equation because it has an equal sign. Okay? So, all right, so the first thing we need to do is actually get our square root, which is this piece right here, get that by itself, right? So if we wanted to do that, we would have to get rid of anything that's on the outside. So you see this 3 right here? That's with our square root. So let's get rid of it. Let's subtract 3 from both sides. Remember, it's an equation, so you got to keep it balanced. Okay, so I'm left with 2x minus 3 equals 5. Okay, so, sorry, my pen is, okay, here we go. Okay, so now we have our radical, it's being equal to 5, right? So remember, our goal is to solve for x, right? So the good thing now is that we've isolated our radical. So we can actually, once we isolate the radical, you can actually get rid of it by doing the opposite operation. So the opposite operation for square rooting is raising to the second power. So let's write that down. The inverse operation for square rooting is raising to the second power. Okay. So if we wanted to undo the square root, right, I'll use a different color so you could see the difference. So if we wanted to undo the square root, we would have to take this and raise to the second power. Whatever I do to my left, though, I have to do to my right, okay? So square root squared, those are going to cancel because they're opposite operations. You know, like addition and subtraction cancel, multiplication and division cancel, square rooting and squaring or raising to the second power. Another way to say that is squaring, right? Those are going to cancel each other. So that's the whole point. So now I'm left with 2x minus 3 equals 5 squared, which is 25. Okay, now it's just a regular easy equation. So isolate your x, so add 3. So 2x equals 28, right? And then divide by 2. So x equals 14. All right. So we've got our answer, but remember, we are not done. We must check. So you must check this answer. And how do we check? Simple, we take that answer and we plug it back in. So we can do that if you want really quickly. So go back to the original and see where x is. So here, let's see. So 2 times 14 is 28, minus 3 is 25, square root of 25, that's 5. 5 plus 3 is going to give me 8, and the other side is 8. Okay, so sometimes it'll be easy to check because sometimes, like you just saw right now, the math is pretty straightforward. So again, what I did is I took my original, and then you see where there's an x, I just plugged my 14 in, and I made sure that both sides were balanced, right? So the right side was 8, so when I plugged in 14, 14 times 2 is 28, minus 3 is 25, square root of 25 is 5, and then I added 3, 5 plus 3 is 8. Okay? Good. Let's go to example 2. Okay, so again, solve for x. Let's see what I have here. 3 times x plus 1 raised to the 2/3 equals 12. Okay, so there are different ways to do this. You can change this so that it looks like a radical. Let me show you what I mean. So the 3 is on the outside. Between the 3 and the parentheses, there's multiplication. So here there's multiplication implied. Okay, now 2/3, how do I write that as a radical? Well, that would be the cube root of x plus 1 squared equals 12. Okay, so I'm gonna change it. Now, do you have to change it? No. So maybe I'll show you 2 ways, okay? So I changed my rational exponent to radicals, okay? And now the same rule applies. Before I do anything with my radical, I have to isolate it. I have to get it by itself. So there's a 3 that's being multiplied. So what I'm gonna do is divide both sides by 3. These will cancel, so cube root of x plus 1 squared equals 4, right? 12 divided by 3. Okay, so now my radical is by itself. So I gotta think about what's the opposite of cube rooting, okay? So the opposite of cube rooting is, think about it, and hopefully you realize that the opposite of cube rooting is raising to the 3rd power. So the opposite of square rooting is raising to the 2nd power, so the opposite of cube rooting is raising to the 3rd power. Okay, so I gotta undo the cube root. So I would undo the cube root by raising to the 3rd power, both sides, right? Okay, alright, so then what do we have? Cube root to the 3rd power, those will cancel. I'm left with, so look at what I'm left with. I'm left with x plus 1. The squared is still there. I didn't cancel this too, so bring it down with you. Okay, 4 times 4 times 4 is 64. Okay? Alright, very good. And then, let's see. We have a quantity squared equals 64. Okay, so we still need x, but x right now is x plus 1. So we have to undo squared. So in order to undo squared, I have to do the opposite of squaring or raising to the 2nd power. So that would be square rooting. Okay, so these will cancel. Then I'll have x plus 1 equals. Okay, so here's the part that I need you to be careful with. Okay, square root of 64, so that's asking what is a number. When you multiply it by itself, that gives you 64. So most of you will say 8, right? Because 8 times 8 is 64. But actually, negative 8 times negative 8 is also 64. So you have to make sure you have the plus or minus here. Okay? So just be careful when you're square rooting something. Sorry, when you're square rooting something and as you're solving for x, you have to consider both the plus and minus when you're square rooting. Okay, so let's put a little star here. Let's see. When square rooting a number, make sure to consider both the positive and negative answer. Okay? Okay, and then finally, remember the goal is to get x by itself. So finally here, what we're going to do is we're going to subtract 1. Okay, and now some of you guys might be lost. Like, how do I do this? Plus or minus 8 minus 1. So this is what this is going to look like, right? Well, this looks kind of confusing. So here's what I like to do. I know it's going to be 2 answers because there's a plus and a minus. So it's either positive 8 or minus 8 minus 1. So here's positive 8 minus 1 and here's negative 8 minus 1. Okay, so what is positive 8 minus 1? So that's 7. And what is negative 8 minus 1? Well, that's negative 9, right? Okay, so supposedly we have 2 answers here. But we must check. Okay, now, do I want to go through the trouble of checking? We could but I'm not gonna do it on the video just because, like I said, I try to keep these videos short. But just to show you, you know what? Let's check one of them. Let's check 7. I can tell you right now they both check out, so they're not extraneous solution. Neither one is an extraneous solution, but let me show you how to check, okay? So I'm just gonna check one of them just to give you an idea. So let's check x equals 7. Now, you could plug it into the original, but I just don't like the rational exponent. I find it confusing, so I'm gonna plug it into the radical version. So it was 3 times the cube root of x plus 1 squared equals 12. Okay, let's plug in 7. So you see where there's an x, I'm going to plug in a 7. So 3 times cube root of 7 plus 1 squared. Okay, so that's 8 squared, right? So that's 64. Is that equal to 12? So remember, you're checking to make sure that both sides are balanced. Okay? So, cube root of 64, right? So that's going to be, cube root of 64 means we're looking for a number times itself 3 times. That would give us 64. So that would be 4. 4 times 4 times 4, right, is 64. Okay, good. Now, is 3 times 4 equal to 12? Well, yeah, 12 is equal to 12. Oops. 12 is equal to 12, so this checks out, so that means that 7 is an answer. Okay, and you're going to do the same thing for negative 9. So if you want, pause the video. Actually, pause the video, not if you want. I want you to actually check negative 9. Pause the video, plug it in just the way I did it for 7, and just make sure that it all checks out. Okay? All right, moving on to example 3. Okay, here's another one. Now this one, I don't know if it's clear enough, but let me rewrite it for you. So here's what they want us to solve. 3 times, so this is the 5th root, okay? Make sure you put it inside this like little piece of the radical. The x plus 1, the whole thing is cubed, 3rd power, plus 1 equals 25. Okay, same rules apply. You have to get your radical by itself. So you see this plus 1, let's get rid of it, subtract 1. So this is 24. And here I'm left with 3 times the 5th root of x plus 1 cubed. Very good. I still have this 3. It's being multiplied technically, so let's divide by 3. Divide by 3, so these are going to cancel. So I'm left with the 5th root of x plus 1 cubed equals 24 divided by 3. So what is that? 8, right? Okay. All right, good. So this is interesting. We have to undo, so we have our radical now by itself. Give me 1 second, guys. Let me see. Okay, so sorry, I was just checking something because I wanted to make sure that I picked the correct problem. Because we're going to get some big numbers here, but that's okay. We can handle it. Just wanted to check that I didn't copy the wrong problem. Okay. Hold on. I don't know what's happening. Okay. So just to walk you through this again, I think I went a little bit fast, but the main point is to isolate your radical first. So I subtracted 1, so I did that first, and then I divided both sides by 3. Okay, so when I did that, I ended up with this. This is an 8. Okay, I ended up with the 5th root of x plus 1 cubed equals 8. Okay, so I have to undo the 5th root. So the opposite of taking the 5th root of something is raising that thing to the 5th power. Okay, and here's where we're going to get a big number. Now, the 5th root raised to the 5th power, I hope we know that those will cancel. Okay, then I'm left with x plus 1, the quantity, cubed equals 8 to the 5th power. Now, what is that? I don't know that off the top of my head. So 8 times 8 times 8 times 8 times 8 is 32,768. Okay, no big deal. We have a calculator that's going to help us. Okay, so I still need my x, right? The whole point of this is to isolate your x. So I have a quantity being raised to the 3rd power. So I have to undo that. So I'm going to undo that. Okay, today is not my day. So this was 32,000. Sorry guys, I'm having a lot of issues today. Okay. We have to undo the raising to the 3rd power, so we're going to take the cube root of both sides. Okay. All right, so what's going to happen here is these will cancel. So I have x plus 1 equals, now what's the cube root of 32,768? I believe that is 32. Let's see. Yes, 32. And you can just use your calculator if you want. But the answer is 32, not 38, sorry. Because 32 times 32 times 32 is 32,768. Okay? And definitely use your calculator to help you out with these powers. Some of them, so in this particular problem, the powers were kind of high. So I don't expect you to know those off the top of your head. Okay, so then we have a plus 1, so we have to subtract that 1. So x equals 31. Okay? So the solution is 31 now. We do have to check it, right? So you're going to take that 31, plug it in, and go from there. Okay, but I believe it does work. Okay, so I think it does check out, but try it yourself. Plug it in, pause the video, plug it in, and make sure that both sides are equal. All right, next problem. Example 4. Okay, another one of these. Now, this one is going to be a little bit trickier, but the same rule applies to start. Let's isolate our square root. So we're going to do that by adding 5 to both sides. Okay, so I'm left with square root of x plus 7 equals x plus 5. Okay, now I'm up to a point where I have my square root isolated. So I have to undo the square root, so I have to square both sides, raised to the 2nd power. Now, this is the annoying part. Now the left is fine because square root and squared cancel, so I'm going to go over here. X plus 7 equals, okay, x plus 5 squared. Guys, x plus 5 squared is not, and I repeat, it's not x squared plus 25. You can't just quote-unquote distribute the squared. It doesn't work that way, okay? So please make sure you don't write that, okay? X plus 5 squared is the same thing as x plus 5 times x plus 5. It's the whole quantity squared. So we have to do a FOIL here, okay? So first, x times x, x squared. Outer, x times 5, 5x. Inner, 5 times x, 5x. Hopefully this is like second nature to you now. And then finally, last, 5 times 5 is 25. Okay, let's combine like terms. So x plus 7 equals x squared plus 10x plus 25. Good. Okay, so our goal is to solve for x now. I think you noticed that this is a quadratic. So with a quadratic, we got to get everything on the same side. And then we're probably going to have to factor, right? So subtract x. 7 equals x squared plus 9x plus 25. Okay. And then subtract 7 from both sides. So 0 equals x squared x squared plus 9x plus 18. Okay, now I don't like my equals 0 being on the left, so I'm gonna erase that and just move that to the right. Okay, here's my quadratic. Okay, everything is on the same side, so in order to solve for x, I gotta factor this. Okay, AC method. So I need two numbers that multiply to 18 and add to 9. Let's see, 6 times 3, because 6 times 3 is 18, and then 6 plus 3 is 9. Perfect. Plus 6 plus 3. Okay. I have two quantities being multiplied to give me 0. Zero product property says take each piece, set it equal to 0, and solve. So x plus 6 equals 0. Solve that. X plus 3 equals 0. Solve that. So here x is negative 6, and here x is negative 3. Right? Okay? Negative 3 and negative 6. Now it looks like I want you to plug these in and check them. It looks like this one checks out, but then this one doesn't. Okay, so that's not a solution. This is the null symbol. I just meant that it doesn't work. Okay, so whatever you want to use to show that it doesn't work, you could just put an X. Okay, but yeah, plug it in and make sure you can tell. Let me show you why negative 6 doesn't work. So let's check negative 6. So check. Okay, so what was the original? It was, let's see, need more space. Okay, square root of x plus 7 minus 5 equals x. Okay, so don't let the fact that there's an x over here confuse you. Just plug in negative 6 wherever you see an x. So this is going to be negative 6 plus 7 minus 5 equals negative 6. So here I have to plug in my x, which is negative 6, because that's what I'm trying to check. Okay, negative 6 plus 7 is a 1. Minus 5 equals negative 6. Square root of 1 is just 1, right? Minus 5. Okay, well 1 minus 5 is negative 4. So this is clearly not equal. Okay? So that's why x equals negative 6 does not work. All right. And then just make sure you check negative 3 and make sure that when you check it works out. Okay? All right, and finally, example 5. So this is a little bit different because as you can see, I have radicals in 2 spots. Okay, so all the problems we've been doing, we just had one radical. But here I have multiple radicals, so it's going to be a little bit tricky, but the same idea holds that you should isolate one of your radicals. Okay, so right now, these radicals are together. You don't want that because that's going to make it harder to solve. So let's get this radical by itself and go from there. So if we wanted to do that, we would have to add square root of x to both sides. Okay, so this is square root of 2x plus 1 equals 1 plus square root of x. All right. Okay, so I know that this is not isolated square root of x, but at least this one is. Okay, so let's try to get rid of this square root right here. So in order to get rid of this square root, I have to square both sides. Okay, so square root of 2x plus 1 squared, that's going to give me 2x plus 1. Okay, now the other side is ugly because basically you have to FOIL this, because 1 plus square root of x quantity squared means, what that means is the following. It means 1 plus square root of x times 1 plus square root of x. So we have to FOIL. Okay, so let's leave. My goodness. Today is not my day. Okay, 2x plus 1 equals. Okay, let's FOIL. First, 1 times 1 is 1. Outer, 1 times square root of x is square root of x. Inner, square root of x times 1 is square root of x. And then last. Okay, last is square root of x times square root of x. Let me show you on the side. Square root of x times square root of x is the same thing as square root of x times x, which is x squared, which is just x. Okay, remember the rule that when you have a square root times itself, square root of 2 times square root of 2, for example, is square root of 4, which is just 2. It's always the inside number. So square root of x times square root of x just has to be whatever's on the inside of the radical, so x. Okay, so let's keep going. 2x plus 1 equals, let me see. 1 plus, okay, square root of x plus square root of x gives us 2 radical x, because we have 2 of them, plus x. Okay, so this is annoying because we still have a square root. So we have to do this problem kind of all over again. So it's another step, right? So it's like in 2 parts. So we have to isolate this square root. So let's subtract 1. Okay, and then actually these are going to cancel. So 2x equals 2 radical x plus x. Okay, let's subtract x from both sides. So 2x minus x is just x equals 2 radical x. Sorry. Okay. So here we can actually get rid of the square root. Now you can divide by 2 if you want. It'll make things a little bit more complicated, but let's do it. Let's get our square root of x by itself, because that's what I've been saying. So isolate your radical. Okay, so on the left I have x over 2 equals square root of x. Okay, I'm gonna square both sides because I'm trying to get rid of my radical, and that's the only way I'll get rid of it. So on the right side, the square root and the squared are gonna cancel to give us x. On the left side, I have a fraction being squared, so I can square the numerator, so x squared, and then I can square the denominator, so that's 4. Okay. Okay, so let's see. Well, here's the thing, actually. I'm gonna multiply both sides by 4. I'll show you why in a second. Okay, so these will cancel. I have 4 squared equals 4x. Okay, and this is looking like a quadratic, so I'm gonna get everything on the same side because it's a quadratic. Okay, because the x's are in 2 spots right now, so I'm not going to be able to solve for x unless I get everything on the same side. So this is going to be x squared minus 4x equals 0. Okay, Now this is a quadratic. It has an a term, it has a b term, but it doesn't have a constant. So you can actually solve this by factoring. So both of these terms have an x in common, so I can factor out an x. So I'll be left with x minus 4, right? Because x times x gives you x squared. X times negative 4 gives you negative 4x. All right, two quantities are being multiplied to give me 0, which means the zero product property tells me I can set each piece equal to 0 and solve. The first piece I don't have to do anything with because x equals 0 is just, you already have x. The second piece, x minus 4 equals 0. If I wanted to solve for x, I would add 4 to both sides, so x equals 4. So the two answers I get are x equals 0 and x equals 4. Okay? So I would go back, plug these in, and make sure they work. The work I have shows me that these two are both good. They're both solutions that work. They are not extraneous solutions. Okay? Now, this problem was a little bit complicated. Okay? So if you had trouble understanding what I did, just rewind, rewatch it, and just, carefully go through the steps. But the main idea is that because there were two radicals, we had to isolate one first, square both sides. That got rid of one radical, right? Here, this is where I got rid of one radical. But then I ended up with another radical. So the second step was to isolate that radical, that radical that I still had. Once I isolated that radical that I still had, I squared both sides, and I ended up with a quadratic. Then I factored that quadratic and solved. Okay? So this is a tricky unit or topic, but I think I'm going to link some other videos that Mrs. Fisk, another Union High School teacher, recorded some videos about solving radical equations. You don't have to take notes on her videos, but I'm going to include them anyway so that you can watch those videos maybe as extra notes, okay? Because this tends to be a little bit difficult. I know you guys are not you're not ecstatic about working with radicals and exponents and stuff like that. So I'll include her video or videos as well. Again, you don't have to take notes on those, but if you feel like you need supplemental material, feel free to watch them and feel free to take notes on them, but you don't have to. Okay? And then we'll go from there.